Yeah.
Negative 37p equals negative 541.
Negative 37p. Oh, I can control it a little bit. There you go. Come on. Yeah, that's pretty good. All right.
I'm sorry, so what section?
2.2.
2.2, number
83.
83, and it said,
Negative 37p equals negative 541.
coolness. So, how do you solve it? Yeah, because the operation is multiplication. So don't add 37, that won't do shit. Addition can never cancel multiplication. You gotta divide by the thing you don't want. What happens to the negatives? And then you just have to do this division. What's the matter? So then, how do you do this division? Is that here? Right? So 37 goes into 54 once, because 2 is 60 something, or 70 something even, more than that, 80 something. So screw 2. Once, 37 minus 17. Four? Yep, 4. So that's 4 times 30 is 120, 4 times 7 is 28, so that'll be 148. Yep. I don't know what it, did the instructions say anything about how far to take this or
No,
something?
the back of the book, the answer says 541 on 37.
Oh, beautiful.
So that's also a question, like when do we stop, right? Because we could do this and keep going
Yeah,
and going and going.
so
But that's also just.
I'll be more explanatory. I'll say something like write your answers in decimal, rounded to blah.
Okay, so if you're not saying.
Or
that,
I'll just say, if I just say solve, this is the solution. So I can't even, I can't even argue about, I'm like, oh, why did you? Well, you should have said something, Jeff, because that's the answer, right?
Yeah.
So if the book doesn't say, leave it in this form, yeah. Now, if you give me an answer, if you work something out and you get P equals 16 over 20, I'm like, you're going to lose a point,
Yeah.
is what you're supposed to reduce that.
Yeah.
So that's not the question here, it's, do I make it into a decimal? Well, if it doesn't say, that's still a valid number.
Yeah.
Yes.
Would you rather us leave it as an improper fraction or a mixed number?
Up to you.
Yeah.
If it doesn't say, that's up to you.
No.
What happened?
I wanted to continue.
I don't want to continue. Because it didn't say to put it as a decimal, so you can leave it like that. Yeah. So if I don't say, or if the book doesn't say, then you solve it. And I'm done. I solved it. That's the number that makes this work. What's 37 times 541 over 37? 541.
No.
And the negatives come there. Oh yeah, the negatives canceled, right? Yeah. All right, how we doing there? Is that all right? Anything else from chapter 2 stuff? You guys are doing chapter 2, right?
Mm-hmm.
Of course you are. All right. Okay, so, yes.
Questions for all the chapters or just the section 1 and section 2?
No, anything. What you got? You have a question?
Yeah, at
Okay.
the end of the chapter.
Beautiful. Tell me. What is it? Sure, go ahead. Go ahead.
Section 2.7, 2.82.
Oh, is this inequalities? With less than or greater than? Okay, we're not quite there yet in the lecture. You're okay. All right. So what I want to do is I want to focus on equations that have decimals and fractions in them. Oh, yummy. That's so creepy. I'm sorry. Well, it doesn't matter. I'm like, ooh, there's yummy. And then we're gonna get into some inequalities. That might be as far as we'll make it today. And then tomorrow we'll have the quiz. I'll have that handout about functions, and I'll have actually the test is I'll have the practice test tomorrow, and then I'll have the answer key on Thursday. Thursday's gonna be nothing but review for the test, because the test is happening the following Tuesday. I'm like, ooh, yeah. Right. All right. So this is with equations with decimals and fractions.
Excuse me, Joe.
Yes.
Class is going a little too fast for me.
Sorry, say again?
Class is going a little too fast for me.
What's up?
Class is going a little too fast for me. I'm kind of behind you,
Okay.
so, I'm not catching up. I'm still on chapter 1 with my homework.
I got you. So, two things. You had questions left over. You can still ask them. Okay, so so you always have the decision to ask a question in class, or come to my office hours and ask me, or go see a tutor and ask them.
Well, I have 7 classes, and I have to go to BOTs, I have 4 BOTs, I have to go to.
Okay,
lab.
so the amount of classes you've chosen to take beyond mine is out of my control, right? So the way you put your schedule together, you always got to make sure that there's enough time for each class. And I don't know if you guys realize this, but I put it on the syllabus too, the what to expect, how much work outside of class to expect.
2 hours.
Yeah, the rough rule is twice as many units as a class is worth is how much outside of class work you should do. And this class is worth how many units? 5. So I think on the syllabus I put 10, I can't remember. So you should expect at least 10 hours a week of outside work, including homework, including just general studying, including going to see me or a tutor, all that stuff. You counted with me? So you got to play off between, like when I was in grad school, I had 3 jobs, and I had to walk uphill both ways. I'll finish it. So I had to let go of finishing some stuff. I just had to, just to make things work. So I didn't finish every homework assignment all the way. I didn't do every project, right? I focused on what was going to help me get ready for a test. I did what I could with the other stuff. Getting it with me? So I had to make it kind of work for me. That's how education works. As a teacher, I have expectations. I'm going to hold you to those expectations. As a student, you're like, I ain't going to ever meet that freaking shit, so I'm just going to do what I can to get ready for what's most important, which in terms of grade, tests are most important because they're the heaviest weighted things. Are you with me? So, in class, like I say several times, and I understand as a student, you're hesitant sometimes to ask questions when it seems like everybody else understands what's going on. That is not true. I can't tell you how many times somebody has I ask, do you get that? Is that okay? And they're like this, and then they die on the test because they were lying to me. And the psychology of that's interesting, right? Because part of it is you don't want to let people around you know something. And I'm like, we're all in this freaking class together. You all are here. You all, for some reason, need to know more of this mathematics. So why hide anything from anybody? If somebody's in here who doesn't really need it, that's their problem, right? Does that make sense? So if somebody around you is like, oh God, don't ask that question.
Exactly.
Say, well, too bad for you. You should really be in a higher class. You're wasting your time. I'm going to freaking ask this
I
question.
agree.
Okay, good. So ask questions in class. If you don't feel like you want to, come see my office hours. If they don't work, email me some options or give me some other options because I'm in my office more often. And if you can't see me in my office at all, go see tutors. I like it. So in class, if I'm going too fast, slow me down. If you want to see more examples of something we've done before, let me know. And part of my job as a teacher is to know when to go, okay, I can't, you got to come see me. I have to keep going to get through this stuff. You with me? That's how this is going to work. Don't hold back if you have questions, because part of my job, like I just said, is to keep us on track. It's not your job to go, I don't want to say that because maybe that'll throw. No, it's my job. Your job is to ask questions and figure this shit out. So if anybody wants to see examples of types of equations we've done before, we can do more. Or if there's specific homework questions I still haven't addressed, or any of that in general. Does all that stuff make sense?
Yes.
I mean, this really is partially making this your own. Right? Yes?
Supposed to do to read this book. So this book is like, there's many, like, examples and questions. So what should we do? Should answer all, solve all the question here? Should we read this chapter before you come here, all the chapter? Because you said you need to
And-
complete everything for the due date for it. So-
In a perfect world, you would have time, you would be able to read through the whole section before the lecture. In the imperfect world we live in, at the very least, you go look at the examples before you do homework so you get a feel for the steps involved, right? That's the minimum. It's better to read some of the stuff so you get some more of the idea behind why the steps are taken, but at the very least, look at the examples and see what's happening. If they don't make sense, maybe read some of the stuff. You with me? So I'm not going to expect you to read every word in a book. I mean, a book is crazy big. But enjoy the hell out of the examples. You get to a certain level of math, and you get a book that has no examples in it. I remember the first class I hit like that. I was like, all right, homework. Wait a minute. Shit, there's no examples of anything. It's just concept, ask you questions. I'm like, holy shit. So enjoy that you have examples still. Enjoy that. What else did you ask? So yeah, you know I assign only certain numbers to the homework, right? You don't have to do all of it. Good. Okay. And this is kind of good. I don't think I said this before. Part of making education your own is saying, that's nice, Jeff, you assigned those homework problems. I'm going to do these that I have time to do. I am going to do my job and say finish or correct or whatever. And you're just going to focus on what's going to get you ready for tests. That's what homework really is. So homework, I give you enough that I think is the right amount so you get practice with an idea enough. You do as much as you have time. So Jeff, again, I was working 3 jobs. I didn't finish any homework. I barely finished any homework assignment, but I did enough of it to get a feel for how to do it. And I did pretty well on the test. It was the homework and the projects that killed me. Right? So I always like to say my report card had a lot of personality. It wasn't just, oh, it was, yeah. Thankfully no, but, all right. Does all that make sense? All that stuff? I mean, yeah. Is that all right? So I want this to be an environment where you can ask any question you want to, and it's up to me to say, okay, you got to come see me. I've got to get back into new stuff. Keep it on track. Okay. So does anyone have anything you want to look at before we get into these weird things?
Yeah, number 6 on 2.2, you think that was together?
Oh yeah, so that thing I gave out last time.
Yeah.
All right. Number 6.
Yeah.
What's that one say? Do I have some more of those? I think I do. Oh wait, that's what we're about to get into. That's why I didn't do all these last time. That's the one that's got massive fractions in it, right?
Yeah.
Yeah. We're about to get into how to handle that. I like it. No. Good try. So the last 2 on here are fractional ones. Number 5 is not too bad because they're LCD. I like it. Yeah, okay. And the other ones are basically the same kind we've been doing.
Can I get one?
Yes.
Okay.
Well, let's just do, real quick, let's just do a couple things. Okay, let's see what happens. I'm just making shit up, not even thinking about it. I have no idea the answer to this. All right, so somebody, that's going, right? Little dude? Little camera?
Yeah.
Okay. Where's what from?
His brain.
This one? From,
Just
yeah,
maybe.
from here.
Oh.
What's the first thing I do up here? Yes. So you train yourself to look for parentheses. Because again, what's the idea behind that? What did I say about that? What are you trying to do?
Trying to
combine like terms, so
Eventually, I want to combine like terms, but if any of the terms are stuck,
you need to eliminate.
I gotta free them up. So I call it like breaking him out of prison, right? Poor little x plus 3 is stuck inside here, there. Sorry. So I want to distribute because that frees up those terms. Then I can put them together with their like terms. Okay. So then I get, so this 4x is just hanging out here.
Minus 2x.
Good. Minus 6, right? Negative 2. And this side, nothing to do on that side. Something to do on this side?
Yes.
Yes.
2x.
And then here's where you can make a decision. Because all you got to do is get x's on one side, numbers on the other side. It doesn't matter which side. So I think I got some of you guys understand. You should be able to do it either way, but which way do I want to do it to be a little more careful? Yeah, to keep things positive on my x. When I introduce negatives, that's another place where we can make a mistake. That's bad. Well, I made it come out kind of neat. I like it. I didn't really. Just careful, what? Add 5, yeah, I'm with you. Good. And again, some people get a little tripped up here, but just what's telling you what to do is why is x not by itself? Nothing else is telling you what to do. All right, so x is not by itself because it's a stupid 4. I'm going to kill that 4, dead. So x equals negative 1/4. Kick ass. Maybe. So there's a central idea behind this. It's always trying to undo what's being done to the x, but that by itself is not really good enough. There's the idea of distribute, so I can get like terms together, so I can work on getting x's on one side, numbers on the other side. With me?
I have a question.
Yes.
Did you leave out 4x in the first? There's 4x, negative 2.
Good.
Then the second line, go down one line.
So there's
right?
4x
Right?
minus 2x
Yeah.
minus 6.
Okay.
Okay.
Mm-hmm.
Equals 6x minus 5. Okay.
Okay. And
What's
then
4x minus 2x?
Is 2.
2x. So this
I see.
is here. Yeah, I like it.
Okay.
So distribute, simplify each side, and then start moving stuff. That's pretty much for equations that don't have like weird shit happening, like stuff is squared or stuff is square rooted, or even like things called logarithms and shit. If they have none of that, then it's basically distribute, simplify the sides, move the variables and numbers. That pretty much covers most of the basic equations you see in chapter 2. Okay. No, yes? Yes, no? Okay. Boring the shit out of some of you, but it's fine. Enjoy that while it's happening. If this is not boring the shit out of you and you're stuck here, let me know. One more example. Let's see what you got, Jeff. This is not too bad. Let's just do this, just to show you how some fractions don't matter. All right.
Yeah, add 2 first.
Add 2, I like it. Because where's your x in this term? Why is it not by itself? Stupid 2. So what do? Get rid of it. Start to unbury your x. So then these cancel. I get x over 3 equals 9. Good. And again, it's always the same idea. What's happening? Undo what's happening. What's the operation? Apply the opposite operation. If there's division, I'm going to multiply.
18. 15. 13.
Hi.
27.
27. Hey, I appreciate the attempt, but you got to memorize those multiplications.
Wait, I got one more attempt. It'll be surprised.
If it's not 27, don't tell me.
Okay.
Okay. So I stuck a fraction in there, but that, I wouldn't really count that as a fraction, right? I would just count that as division that I eventually undo. So let's do a problem where there really is true fractions in it. Yay. Eventually, we're going to build it there. Let's see. I want to start off with something a little bit. Just do it, Jeff. Okay, man. Let me show you. I want to get you the idea. This has got a very. This one is not bad at all at first, and not as bad as it could be because it's all the same right. So this problem, every fraction had the same denominator, right? It's only one fraction, but still, it's the correct thing to say. How did I eventually take care of it? Multiplied by that bottom. Right? I could have multiplied by 3 first, as long as I did it to everything, because whatever you do to one side, you have to do the other side. And you see how, so what's creating fractions? The division by 4 everywhere. So how do I undo that first? Multiply everything by 4. So if I multiply this side by 4, and do you see how I would distribute? So I just put 4 next to everything instead of just, and then multiply everything here by 4. You with me?
No, you chose 4 because it's the.
Why did I
CD.
choose 3 here? If you're okay with this problem, why did I choose to multiply by 3?
Yeah,
Because it was being divided by.
3,
What's everything being divided by?
4.
And I'm allowed to do multiply, divide, add, subtract from both sides, the same thing, and that's fine.
Okay.
Except 0. I can't multiply by 0. Or divide. Everybody with me? I am totally allowed to multiply both sides of an equation by any damn thing I want to, and it stays true. So the 4's cancel. And what are you left with? X minus 3 equals 7x plus 5. No, all right. I don't know if that was real or sarcastic.
No, I just thought that was real.
Real?
I had
Okay.
to do some-
Because the next thing some of you guys should say right now, or you're thinking it is, well, Jeff, they ain't always freaking 4s and 5s. Sometimes it's 8s and 3s and 5s and bullshit, and you just made one really easy. All right, I'm working up to it. The idea here is if the bottoms are all the same, I multiply by that. And then I have no fractions left. So if the bottoms aren't the same, what's my first thing that I'm going to do? Make them the frickin' same, LCD, which you should know how to do. And once I get them all to have the LCD, I multiply by that number, no fractions. That's the beautiful thing about equations. Almost anything that makes an equation hard, you can kill that thing. Because you're doing something to both sides. Notice how I cover my ass and said almost. Some things you can't. It's like whack-a-mole. I killed it. Oh, gross, it's on the other side now. Ah. And now it's easy. Is it okay if I say that? All right. This is compared to where it was. Isn't that what level am I at now? What do? No.
Like you subtract x.
Get my x's and numbers together. So yeah, I like that. Subtract x.
You subtract 5.
Subtract 5.
Divide
Divide by,
2.
no, 6.
That's
Don't
right.
think about what goes in both. You've got to kill the 6. You got no choice here. Kill the 6. And then, of course, what do I do with this? Reduce.
X equals -4.
Kick ass. All right, so let's do one where the bottoms aren't the same. Yeah.
Just for instance, this is a random one maybe, but like -5/6 r plus 2/3. This is just off the
Wait,
top
wait,
of
wait.
my head.
Okay, hold on. Off the top of your head?
Yeah.
As you read it out of somewhere?
No, I'm not.
Oh, you wrote it
I'm
down?
reading it out of my mind's eye.
is that a problem?
No, it's actually number 6. Not
My
4.
mind's eye is
Negative 5 over 6 times r plus 2/3 equals 5 over 2 plus 1/2 times r plus 16/3.
Kick ass, I like it. Okay, let's do it. Are the bottoms the same?
No.
Can you figure out the LCD for everybody?
6.
Yeah, you guys see that? LCD 6. Now there are two ways to do what I'm about to do, and I like to do it the way I'm showing you right now because it helps. Eventually, we're going to get to the point where there's not just numbers down here, there are also variables on the bottom.
That sucks.
Like there'll be an x minus 1 there, there'll be an x plus 7 over there. So the way I'm about to show you is the right way to look at things to be ready for that. There's another way to do this that other teachers might have shown you that works great for this, but doesn't get you ready for that. So there's always a method to the way I pick sometimes. I like to always in the simple.
How come the LCD is 6?
So every single bottom can multiply up to be 6. 6 has 2 and 3 in it. So I don't need to change him at all. I can give him the 2 and him the 3. I can make everybody become 6. Kick ass. So it's really nice when there's a number that all the other numbers go into. Then the LCD is an easier process. So we don't have to change him. What's he need? He's a 2. What's he need? 3. What's he need? 3. And he needs 2. Now, some of them might be hers. I don't know the biology of this. Sorry. So then you get negative 5/6 r plus 4/6 equals 15/6 plus 3/6r plus 32 over 6. And what's the great thing you can do now? Multiply both sides by 6. So hopefully at this point, I don't have to put it next to everybody. That 6 cancels, it distributes and kills that 6, it kills that 6. The worst thing is when somebody puts a 6 here and they cross through that, but then they put a 30 here. That 6 is dead, right? It gave its life to kill those evil 6s. Heroic 6 kills these guys, and it dies. Poor little thing. It's not like Arya. Didn't survive this after that. Sorry. I'm sorry I referenced the horrible season. Yes?
So on a test, if we skip the top line and just multiply the whole thing by 6.
That's
right
the way I'm
away,
talking about. That's a valid way, but it doesn't prepare you conceptually
Yeah.
for when the bottom comes variables.
Okay.
This way does. Either way, you get to the same place.
Okay.
So just so you guys see, the other way is to multiply by 6 right away. If I multiply this by 6, do you see how 3 goes into 6 twice? 2 times 2 is 4. I mean, so of course you're going to end up with the same answer either way, but this way just gets you ready for something coming. So what's left alive?
Negative
5r.
Negative 5r
plus 4
plus 4.
equals
15.
plus 3r plus 32.
All right, that's still not beautiful, but it's a hell of a lot better, right? Immediately. The trade-off is the numbers are a little bit bigger, but hell, no fractions. So now this should be relative. Go ahead and finish that up. Shouldn't be overly difficult. There is simplification to do on one side, right? Let's see if this is going to go anywhere good. No, not really. Oh, well, you get a nice fractional. Hmm. Yes, we'll do some more of those. We've already done some of those. Yes, we sure did. We did examples of all real numbers and no solution equations. Yes? Didn't we? No, maybe not. That could be crazy.
Now on this side, the right side.
Yeah, this side you can do something, right?
No, I'm still up there. Sorry,
Oh.
you're going way too fast. It's 3. Where did you pull 3 from?
So
5
notice
times
how
3,
the fractions
right?
don't at first have the same denominators, right?
Exactly.
So all I'm doing is multiplying top and bottom so they end up with the same. So what's a 3 need to become 6 times 2? Same thing at the top to keep it legal.
Thank you.
Notice how the rule is always do the same to both sides. Left side, right side, upside, downside. Right, or the upside down? Yeah. The upside down. So then you get 3r plus 47. Subtract the, well, let's see, which way did you guys go? Did you add the 5r first? I like it.
Subtract 47.
Subtract 47. And then
R equals negative 43.
divide by 8. Yeah.
Let's do the, I did the minus 3r. What do you want to do?
Well, if you do minus 3r, then negative 5 minus 3 is negative 8.
Yeah.
Same sign you have.
I did that way wrong, yeah.
I see where you got the 2. Yeah.
Yeah.
All right. That's how you can do. Now, watch this. Let me do an example where there's one thing you gotta be careful about. And then we'll do a decimal example, and then I think it might be time to head out.
It's 140 right now.
Yes. It's 140. It's 139. Ugh. Take that sad.
Wait 30 seconds and I'll be right.
So let's look at this one. All right. Let me ask you a question. Just looking through that thing, okay, identify which piece is a little bit different that you got to be careful about. That somebody might make a mistake with. Like if I say, what do we want to do here? We want to make what happen? We want to make all the denominators the same. Which denominator is it really easy to forget?
One.
Yeah, the one under the 3. You're not allowed to leave a piece alone because we're going to multiply both sides by something. It's going to affect this guy too. So you got to include him. So any whole numbers in the thing, if you're going to do some fractional stuff to it, put it over 1 so you don't forget them. They have denominators too, it's just they don't show up. Poor little thing.